All right. So part A, we want to solve that merge sort problem, or we want to learn another sort algorithm, merge sort. So let's start from the very beginning. First, I give you our problem number 16, merge two sorted arrays. A subproblem. Yeah, actually, this is a subproblem of our original sorting problem. Given two ordered arrays, both ordered. So this information is important. Okay? How to merge them to get an ordered array. Okay? So this array should contain the elements from these two so let's do not call subarray, smaller arrays. All right. The question is why we need to study this problem. Okay? Our goal is sorting. Why we need to study this problem? So at the beginning, I want to give you the motivation argument. Yeah. So let's look at the motivation first. Why we need to consider this problem. Yeah. So here, the story like this. We know we want to solve the sorting problem using divide and conquer. Right? Yeah, divide and conquer. So we use it to solve several problems, but this time we use it again to solve the sorting problem. But we want to do something better. Yeah. So the older way we solve, we feel still there is something not quite satisfied. Yeah, so why? Think about what is the overall performance of selection sort. What is the overall performance of the selection sort? That is big theta of n squared, right? What is the overall performance of bubble sort? Also this one. What is the overall performance of the insertion sort? Also this one. So you can see all these three sorts we have learned so far all belong to this category. And we are not satisfied with this category. So our goal, we want to get a better, faster category. So that is big theta of n log n. How do we get this? So that's why we need to use divide and conquer again in a different way and solve that sorting problem another time, but this time we want to achieve this goal. Okay? So that's the, original, starting point. Okay. All right. How to do the divide and conquer. Yeah. So before we go that story, that part, so let me ask another question. How to sort a huge array? Huge. So you can imagine the number of elements in this array. Let's say in billions. Okay? So if in millions, so we may not feel it is a huge array, right? So let's think about in billions category. Okay? That should be huge, right? How can you sort an array with billions of elements? Imagine that. Okay? Yeah. So here, divide and conquer. Can you do divide and conquer? The huge array, can we divide it into smaller subarrays? Right? Divide and conquer. Yeah. So let's look at the idea, divide and conquer. Yeah. So this whole line segment represents the whole array. Billions of elements. Now let's divide it into smaller subarray. So here right now we have the computing resource. We can do parallel computing. So think about, so right now a multi-core and think about server, server farm. Think about, so a lot of computers, parallel computing available. So can we use that resource to sort this huge array? Right? So let's divide it into many smaller subarrays. Then for each subarray, because the size is relatively small, so we can use the, some sorting algorithm we can sort easily. Yeah. So let's assume we sort each subarray in a normal way. Okay? After that, how can we get one final overall sorted array? How can we do that? Now, our question number 13 is a reasonable question, right? No, this time it is reasonable. So, because if we can solve problem number 16, we can merge these two arrays, then merge. Finally, we get one big overall ordered array. That's our plan. Yeah. Looks reasonable, right? Yeah. So that's why we go this direction. All right, so let's go to the next step. How to merge two sorted arrays. We know this step is important. Yeah. So we want to do it. We want to solve this problem first. All right. Given two arrays that are already sorted, so we assume that, based on the story we had in the previous slide, how to get a new sorted array that contains all the elements. We want to take advantage of the structured data. Our data has nice structure, sorted. Each individual array is sorted. That information is important. So we should not throw away that valuable information. We should use it. Okay. All right. So when we pick, so right now we need to pick the right sort algorithm. So do not use any sort that does not make use of, so think about this, does not make use of any order information. We have many sorts. Some of them, they never use any order information, right? Yeah. So we should not choose those. So let's see the three sorts we have learned so far. First, selection sort. In selection sort, do we use any order information? No. Selection sort does not use it. Bubble sort, do we use any order information in bubble sort? It does not. Okay? Then insertion sort. That's different. For the insertion sort, we use the order information a lot. A lot. Remember the key insertion step. How do we do the insertion step? Insert an element in an ordered array, right? So we use that information here. So that means this insertion sort is the choice. Okay? Yeah. So another point I mentioned in the insertion sort, it is good for almost sorted array. Almost sorted array. Okay, so here you can see it uses the order information. Almost sorted array. Can we treat two sorted arrays, if we put them together, can we treat them as almost sorted array? Kind of, yeah, but not quite, right? Yeah, not quite. It's hard to describe in that way. Yeah, but the good thing is there is some similarity. Yeah, so we can use that. All right. Now we want to take a different view on the insertion step. Yeah, because that's our background, that's our experience. This time we want to use that experience, insertion step experience, to try to get some new idea. So why we take a different view? Yeah, so it's simple, to get a new idea. Yeah, using this new idea, we may get some improvement in our sorting. All right, so let's go back to this typical insertion step like this. Okay. All right. In this step, we know this is an ordered array. Okay, it looks nice, satisfy our requirement. But how about this one? One element. What's that? Can we treat it as another ordered array? It's a single element. Yeah. But we can treat it as a special case of an array. One element array. And it is sorted. So here you can see, if we use the view of two ordered array, the situation, we have that pattern, right? That requirement. We have that. Okay? So here you can see. So we have that two ordered arrays, but the problem is the problem size is quite different. Yeah. So let's try to get around this difference. Okay. So the new interpretation. Based on this new view, we have a new interpretation. Two sorted arrays are combined to get a new sorted array. Yeah, so our insertion, so we combine two sorted arrays. Our new view, so it's a merge view. Now, it's not an insertion view. Now, we look at this as a merge view. How about that? Okay, merge view. Merge two sorted arrays for a new sorted array. Okay, so this new view. Yeah. And here, how to merge? This merge is important step. Yeah. So we use this word, but we need to consider how do we implement? How do we make it happen in our computer algorithm? Yeah. So we need to do more. Yeah. Apply new merge view. Merge two solid arrays this time. All right. Here we have two arrays. Yeah, the size is quite different. Okay. Data size, the first one size k, the second one size 1. And we can see it is not balanced. Skewed, okay, not balanced. Yeah. Based on our experience, this unbalanced situation may cause poor worst case problem. The worst case could be very bad because it's not balanced. That's from our experience. Okay? Yeah. So we want to improve the performance. So improve performance for the worst case. We know by the balancing principle, we try to make two subarrays of equal size. That's based on our balancing principle, as equal as possible. Close to equal. Okay? Not necessarily exactly equal, but as close to equal size as possible. That can be done easily, right? So that's based on the balancing principle. So we learn from that fake coin problem. Fake coin problem teaches us this important principle. So we use it here. Okay. All right. So this is the introduction part. So I explained the background, why we want to take the merge view and what direction we should go. All right, so we complete the first video. In the second video, we get the details of the merge step. All right, let me stop here.